Chapter 4, Lesson 7, revisits the concept of linear and nonlinear functions. So we've had these before. We have determined whether something is linear or not, and we determined that if we looked at the rate of change and if it was constant, then it was linear. So with that being said, let's look at example 1. It says determine whether each table represents a linear or nonlinear function. Again, we've done this before. So you look at, remember, it's always the change in y over the change in x. This changed by 15, this changed by 15, this changed by 15 between each of these, and the x is changed by 2. So what is the rate of change? Negative 15 over 2. Now, it didn't ask you what the rate of change was. It just says, is it linear? So if it is constant every time, it is linear. That's why 1 is a linear function. Looking at 2, this side went up, the x's went up by 3 every time, but if you look at the y's, from this y to this one, it went up 15, then it went up 33, then it went up 51. The rate of change is not the same. So this is not the same. So 2 is a non-linear function. Now, it said you can check by graphing. So if you had this graph, now I wouldn't ask you to graph something this large necessarily on your homework, but if you did, it would be 1, 1, 4, 16, 7, 49, 10, 100. Look what's happening here. This is not a straight line. This is actually a curve, and it will continue on. This is what happens in the next lesson when we talk about quadratic equations, whenever the x value is squared or one of the values is squared. So this is not a straight line. This is actually a curve. That just goes to illustrate that this was a non-linear function in example 2. Okay, moving on to the next page. Oh, yeah, I guess we need to try some of these, don't we? Okay, I want you to pause and try A and B, please. Pause and try A and B. All right, back with me on A. Look at the change. So the x's go up by 5 every time. The y's go down by 4 every time. And again, it doesn't matter that one goes up, one goes down. One's an increasing function, one's a decreasing function. But again, it's still a function. But what we are looking at here, not necessarily what is the rate of change, but is it linear or nonlinear? So A is a linear function because the rate of change stays the same. When you look at this one, the x's go up by 2 every time. And the y's, that goes up by 2. This goes up by 6. This goes up by 10. So the rate of change is not the same. So this one is a nonlinear function for B. All right, again, we've had all this before. They're just trying to prep you for what's coming next. So I think this is kind of a review lesson. All right, looking at example 3. Use the table to determine whether the minimum number of calories a tiger cub should eat is a linear function of its age in weeks. So again, don't get caught up in the wording of that problem. You're just looking to see, is this linear or not? So if these all go up by 1, right, age in weeks, they all go up by 1. What about this? This one goes up by 175. The difference here, 185. The difference here, 135. And the difference here is 100. So would you consider that a linear function? I don't think so. It is nonlinear because the rate of change is not the same. So try C. Pause it and try C, please. All right. Tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? Are the ticket sales a linear function of the number of tickets sold? So each of these is going up by 1. These go up by 5. Yep. So the rate of change is the same. So you would say linear. And if I had to explain, I would say it is linear because the rate of change remains constant. Okay. Now let's move on. And we won't went too far. I mean, really, it actually behaved itself during the last video, and so far this video, that is like even the wrong lesson. I'm gonna have to pause this a second. Okay, yep. See, it went back to the complete other lesson. It can't be good for 2 videos in a row. That would be just crazy talk. All right, so let's try example 4. A square has a side length of s inches. The area of the square is a function of the side length. Does this situation represent a linear or nonlinear function, and explain? So looking at this, I'm going to do nothing more but look at the rate of change. So as these all go up 1, this goes up 3, this goes up 5, 7, 9. So is the rate of change the same? 3 over 1, 5 over 1, 7 over 1, 9 over 1? Absolutely not. So they are not linear. It is a nonlinear function. And if we graphed these, you would see that it actually is an exponential function. So a quadratic function, which we will talk about in the next lesson. So the area of a square, and think about the area of a square. Wouldn't you take the side times itself, so the side squared? So this is setting you up for 4.8. But just that way you know the difference between a linear and non-linear function. All right, so we've got one more for you to try. One more for you to try. And boy, this is going to be a short lesson. Yay, you. All right, got it. Pause it and try it, please. Back with me. A square has a side length of s inches. The perimeter of a square is a function of the side length. Does this situation represent a linear or nonlinear function? Explain. Okay, so you can come at this a couple different angles. If you want to think of it as an equation, so the perimeter, how do you get the perimeter of anything? Considering, okay, you add all sides together, all right, but considering that this is a square, you know that a square has 4 sides, and all 4 of those sides are the exact same length. So I could say that the perimeter is 4 times s. Perimeter is 4 times s, so 4 times the side length. All right, so does the situation represent a linear or nonlinear function? Well, is this not even a direct variation form? Something equals mx, y equals mx. I mean, different letters, but it's the same concept. Or if you even wanted to come up with a chart, let's try 4 different numbers. Let's say that this is the side length and this would be the perimeter. So if I had a square with a side length of 2, 3, 4, and 5. So if each side of my square is 2, then my perimeter would be 8, right? So 2 times 4, which is what we got right here, is 8. What if they were all 3s? Yeah, magically changed those 2's into 3's, didn't I? 3 times 4, 12. If they were all 4, 4 times 4 is 16. If they were all 5, 5 times 4 is 20. Let's look at the rate of change. So as these all increased by 1, what did these increase by? They all increased by 4. So the rate of change would be 4. So the rate of change is constant. It's constant 4 in between all those. So yes, this is in fact linear. Okay, so with that, I think we're going to call it on that. Like I said, this is all review. We are looking for the rate of change to remain constant. If it does not remain constant, it is nonlinear. Nowhere in here am I asking you to find the rate of change. It's just saying, is it linear? Is it nonlinear? And you have to tell me. Because again, whenever we go into 4.8, we're going to have some functions that are not linear. Okay? That we're actually going to have some exponential ones. So with that, consider this an easy day, easy lesson. Good luck.